Okay, in this video we're going to look at solving some more difficult equations and absolute value problems, some that require more than just a couple of steps. And so if I'm looking at a problem, the way that I would approach these is I first look to see if there's any terms that I can combine on one side. So I look here and I have two terms that have x on them. They're like terms, so I'm going to put them together. So that makes -5 equals 5, and then 6x minus x is positive 5x. And then now from here, we work to isolate the variable that we're solving for. So I'm just going to leave the x where it's at. So the 5x is going to stay on the right-hand side. So I'm going to work to move things away from it. And you start by moving any adding and subtracting. So I'm going to first move the 5 that's on that side. And to move it is currently positive. So to move it to the other side, I have to subtract it. So I got a -5 from both sides. That's going to take it away from right here. And then now we work to make our next line. -5 minus 5 makes -10. And then I have equals. And then I still have positive 5x. I don't need to write the plus sign there. And then last part left is to get the 5 that's timesing to the x off of it, which means to move it I need to divide. So I got to divide both sides by 5. And that takes it off of the x. So the right side is equal to x. Left side, -10 over 5 is -2. All right, this one here, working to solve, there are no terms I can combine right out of the gate. In fact, if I have to distribute to expand this problem before I can condense it by combining like terms. So I got to take that 3, and I'm going to have to distribute it to everything on the inside. So let me start by writing 75 equals. I start multiplying the 3 to the 6b. That gives me 18b. And then I got to take that same 3, and I have to multiply it to the -5, which gives me net -15, and then drop down that -3b. And now we're here looking to try to combine like terms. Well, on the right-hand side, I have 18b's and -3b's I can put together. That's going to give me 15b's. And then I still have -15. And then now we're in a simple two-step equation. You look to move any adding and subtracting away from the variable first. So I'm going to move that -15 to the other side by adding it. That's going to give me 90 equals 15 times b. And now I got to take the 15 that's multiplying to the b off of it. Well, to undo multiplication, we're going to divide. So I'm going to divide both sides by 15. That's going to take that 15 off of that b. So the right-hand side is b. And then 90 divided by 15, that is 6. So 6 is equal to b. Now we encounter a problem where we have a variable on both sides of the equation. And the way you choose to proceed here is kind of up to you. Me personally, I like to pick what side I want my x's on. It doesn't matter. Your x's can be on the right side when you finish, or they could be on the left-hand side when you finish. And that choice is up to you. I'm going to say, let's have all of our x's on the left. So I'm going to take the 3x on the right-hand side and move it to the left side. Well, it's currently positive on the right. So to move it to the left, I got to minus it. And then I'm going to rewrite what I have. So I have 5x minus 3x is positive 2x equals -11. And then now we proceed like we have done with all the other ones. So now that my x's are only on one side of the equal sign, I start moving everything else away from it. So I got to move the 1 by subtracting it. So I have 2x is equal to -11 minus 1 is -12. And now we divide by the 2 that's multiplying to the x. And that's going to give me x is equal to -6. Here we have variables on both sides of the equal signs, but I can't necessarily move anything until I apply the distributive property and fully expand the problem. So that's how we're going to proceed. So I'm going to start rewriting the problem here. I got 6 plus, I got to take that 6 that's outside of the parentheses of the k plus 1 and multiply it to everything inside of there. So plus 6k, and then 6 times that positive 1 gives me positive 6, so plus 6 equals, do the same thing here with the 2. 2 times 4k gives me 8k, and then 2 times negative 6 gives me negative 12. Now we can look and say, all right, well, I'm going to look to combine like terms. I have 2 6's on the left-hand side, so I can put them together. 12 plus 6k is equal to 8k minus 12. All right. Now that there's no terms left to combine on either side, I got to pick what side I want my variables on. Again, it doesn't matter. For this problem, to avoid having a negative coefficient in front of k, which really doesn't matter, I'm going to move this 6k to the right-hand side. So I'm going to subtract both sides by 6k. Means that's all that's left on my left is going to be a 12. 8k minus 6k is positive 2k, and then minus 12. And then now we isolate the k. So I move adding and subtracting first. So I'm going to add the 12 from the right side to the left. It's going to give me 24 is equal to 2k. And then lastly, we move any multiplication or division. So I'm going to divide that 2 off of the k. And that's going to give me 24 divided by 2 is 12. So I got 12 equals k.